In this video, I'm going to introduce binary numbers. To start with, let's review how our decimal system works. We have columns, and each column is a power of 10. So there's a ones column, a tens column, and a hundreds column. So if you want to know what this digit represents, you have to look at which column it's in. So this is 300, this is 60, and this is 5, and that's adds up to 365. That's how this works. But why do we have 10 digits? Probably because we have 10 fingers. But this system works no matter how many digits you want to use. And computers can only use 2 digits because we have either voltage, which is on, maybe 3.3 volts, or off, 0 volts. That's it. So you only have 2 values. And so the 2 values that we use are 1, 0, and 1. But we still have a place value. So this is the ones column, which is 2 to the 0. This is the next power of 2, just like we had the tens column. Now we have a twos column. Then we have a 2 squared column. And we have a 2 cubed column. And so you only have 2 digits, so you have 0 and 1. So you can make a number like this. And 1010 is a number that's represented, and let's see what it is. We have 1 4. We don't have any 8s. We don't have any 2s, but we do have a 1. So this represents 0101 represents a number, the decimal number 5. So if you want to convert from binary to decimal, just remember the places. We have a 1, 2, and a 4. So if you add those up, this is 7 base 10. I'll put a little 10 there to show that's base 10. This one, this is, remember the 8s column here, and we have a 16s column there. So we have 1 16 and 1 8, which is 24. We have a 32, a 16, which is 48, plus a 2, which is 50, plus another 1, which is 51. If you want to go backwards or go the other direction, we need to think about what the columns are, and we have to try to find the biggest number that'll fit inside a column, that'll fit inside the number. So the biggest number here is 47. In 47, we can at least fit a 32 in there. How many do we have left? That's 15 left, right? So we can't fit a 16 in there. Let me fix this mistake here. We can't fit an 8. And we're down to subtract 8. We have 7 left. And if you add up all these, this is 7. So the number 47 is 101111. I'm not going to finish the 120, but the 255 turns out to be 1111 and 11111. Anyway, 8 ones. You can do arithmetic in base 2 just like you can do arithmetic in base 10. The process is still the same. If you want to add numbers, let's just add. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 2. Oh, wait a minute. I can't put a 2 in there. I have to put the number 10 is the number 2. So we have to put the 0 down here and carry the 1. We have a 1 and a 1. That's 2. So that's 0, carry the 1. 111 is 3. That's 1, carry the 1. And you can add very nicely with with binary, and even multiplication works the same way. We just multiply. So we just take them in turn, multiply the 1 by 0, multiply the 1 by 1, multiply the 1 by another 1, 0, 1, 1. So essentially, look at that. We just copied that number down below. Now we're looking at this, so we have to. Oh, actually, we can multiply it by 0. There's all zeros there. Probably isn't even worth writing this. And then next, one we're looking at now is 2 places in, so we'll put 2 zeros there, and then now we multiply again. 0, 1, 1, 1, 0, 1, 1. Let me clean this up to make it look a bit easier. You notice what this multiplying, how easy multiplying turns out to be? We're essentially taking this number and either writing it down perhaps in a shifted place. So if we add these up, then we'll get the answer to what these two multiply together. You notice we don't have to go convert back to, oh, what are the chances I get this right? Probably slim, but let's see if that works. So I think that is right. Let's go on. So one binary digit is called a bit, and that bit is short for binary digit. And 8 bits is 1 byte. And in the olden days, 1 byte was the biggest addressable unit, or the smallest addressable unit you can have as a word. But right now we have not just 8-bit computers, but we have 64-bit operating systems. Anyway, if you take 1 byte and you plop all ones inside of it, the biggest number you can get is 255, which means there are 256 different values, 0 plus all of these going up to 255. And that's why you see that number all over the place in computers. If you're picking colors, you can pick red values, green values, and blue values by picking numbers between 0 and 255. So this one has a lot of red in it. This one has a lot of green in it. And you also see that 256 in different times of memory. You also see numbers like 64 and 32, all the powers of 2. Those are computer numbers. And that's it for binary. Introduction anyway.